Hello. In this unit, we're going to talk about Cartesian coordinates and the Cartesian coordinate plane. Now, that's a big fancy name. Well, what does it mean? It's a way of representing whole math processes on paper. And to understand these math processes and what they look like on paper, first we have to understand the format in which they're written, and that's Cartesian coordinates. The Cartesian coordinates are similar to maps, so let's take a look at a map as an example. Now, here I have a map of the United States with a star right where our nation's capital is located. And we're used to looking at maps, whether they're paper or online or part of an app. I use Waze, maybe you use something different, but we all use apps with maps on them. Think of a map as having a grid overlaid onto it with each square labeled. And across the top of the map, we have longitudinal numbers. And down the left side over here, we have latitude numbers. So we could say that our nation's capital is located right here. We draw a line up to our longitude and we get 77, and a line to the left for our latitude, we get 38 degrees and 53 minutes. So we could say that our nation's capital is located at 77 degrees, comma, 38 degrees, 53 minutes. Drawing a line from any longitude and latitude onto the map results in a very precise and unique map location. And there's one assumption that we're working with here. Which number comes first, longitude or latitude? Well, there's a standard for that. Map makers always write longitude first. Map readers know that the order then is longitude and then latitude, and we all just sort of agree on that standard. The Cartesian coordinate plane works almost exactly the same way. And it's not as friendly, it doesn't have pretty colors and familiar places, but it is a grid plane where we can use pairs of numbers to identify unique locations on that plane. The x-axis, like our longitude, runs from left to right and measures horizontal location. The y-axis, like latitude, runs up and down and measures vertical location. And at the center is a very special point called the origin. And we say that its coordinates are 0, comma 0. That is where everything starts, or where we start measuring from. So let's look at a few points on this plane. This green point up here is labeled 2, comma 3. It's in the upper right of the grid of the plane. It's 2 units to the right of the origin in the x direction and 3 units above the origin in the y direction. So that's why it's labeled 2, comma 3. X comes first and then y. Now, one way that coordinate plane differs from a map is that we can have both positive and negative numbers as our coordinate values. Positive values are found above and to the right of the origin, and negative values are found below and to the left. So this blue point down here, it's labeled -1.5, -2.5. It's located 1.5 units to the left of the origin in the x direction and 2.5 units below the origin in the y direction. And we can also mix positive and negative values to find locations, such as this -3, comma 1 point over here. Now, in previous units, we introduced you to two variable equations, and they can be graphed on the coordinate plane. An equations graph looks like a line. To make that line, I'll need at least two sets of values, two x's and y's, that work with this equation. So to get my values, what I'm going to do is make up some x values at random. Doesn't matter what they are. These guys, I just kind of pick them out of thin air. But then I'm going to find the precise y values that go with each of the x. So if x is 1, substituting that into my equation, I get 5 for y. If x is 0, y must be 3, and so on, as many values as I'd like to calculate. I only need two values for a line, but I've given you 5 here to give you a better idea of how it works. So now we'll plot those values. Here are our coordinate pairs. X is 1 and y is 5 is located in this unique position on the plane. 0, comma 3 is located in this unique position, and so on for each value. And we can see that these fall in a nice straight line on our coordinate plane. This line is the line of y equals 2x plus 3 values. We can see some important characteristics of this line. So for example, it rises going left to right, and we can see the points where it crosses the axis, and those will be very useful later on. and that is the Cartesian coordinate plane.